Calculating matrix inverses. We can calculate a matrix inverse using the Gauss-Jordan method. So here's the statement of the problem. We have a matrix A. We would like to calculate the inverse. So the first thing we'll do is form this augmented matrix. So what we do is we have our matrix A right next to the identity matrix of the same size. So here is our augmented matrix. So of course, this is just a 3 by 3, so we can see all the elements. So we also have a 3 by 3 identity matrix. What we do is we apply the Gauss-Jordan method until all of the elements on the left take on the form of the identity matrix. So we're doing these row operations, adding and subtracting integer combinations of other rows until we get this identity matrix on the left. Then what we're left with on the right is the matrix inverse. Now here's the most important part. What's left here is not the answer to the problem, and I have a lot of students report this, and I always mark it wrong. You have to extract this matrix over here, and that is the inverse of A. This is the augmented matrix. Yes, it has the matrix inverse in it, but that's not the answer. We have to extract the answer and write it this way. Here is the matrix inverse. We can also calculate matrix inverses using LU decomposition, or really any kind of algorithm for performing backward division. Here's how that would work. So we have our matrix A, and of course we have this unknown column of x's. So what we'll do is one at a time, we have this column vector on the right. We will put a 1 in the first position and zeros in the remaining. And so we'll apply LU decomposition, or really whatever our solution method is, but we'll apply LU decomposition to solve for this column vector of x's, and we get an answer. That is the first column in the inverse matrix. And we simply go one element at a time, one row at a time. So we put in all zeros in this column vector on the right. We put a 1 now in the second column. We solve, and the answer we get is now the second column in the matrix inverse. And then we iterate through all the rows, and finally we end up with all zeros, a 1 in the last position. We solve for our unknowns x, and we get some column vector, which is the last column in our matrix inverse. So of course, hopefully from this, you can see how you could extend this to any size matrix just by going one row at a time and putting a 1 in that position, and then that becomes that particular column in the inverse matrix. From the bottom of my heart, thank you very much for watching this video. I love hearing your stories about how these videos helped you. I also love answering your questions. So please tell me your stories and ask your questions in the comment section. I promise I will try to answer every single question that's asked. If you like this video, hit the like and subscribe button. I also recommend visiting the official course website that has links to the latest versions of the notes, the latest videos, and there's lots of other resources to help you learn, including implementations in MATLAB. I'll see you in the next video.